question, because we are not only covering the answer of this question. Okay, we are also looking for the tricks that may be related to this question or the other questions. Okay, so let's start and go ahead. So the first problem is 27. Consider the uniform electric field E4.0 J direction. Okay, so let's choose the color. So this is 4.0 in J direction and plus 3.0 in K direction, and all of these are multiplied with 10 to the power 3 Newton per coulomb. What is the electric flux? So we have been asked to find the electric flux phi through a circular area. So the area is circle, and that circle has 2.0 meter in radius that lies in the XY plane. Okay. So before we go and solve this problem, actually, we know in general, phi, which is the flux, electric flux, depends on the electric field, okay, as well as area. Okay. And before we go and solve the problem here, we should know that the electric field here, okay, sometimes it is constant or uniform, as in this case, you see, uniform electric field. So if it's uniform, so then we take it as it is. It has only one value, ثابتة, okay, constant. But if it's not constant, if it's changing, so then we have to sum all of these small values of electric field. And then we call it sigma, or we call it integration. So we want to add up, sum up, نجمع جميع اللي هي القيم للمجال الكهربائي إذا كان مختلف أو متغير. Something else here also is the area here. Okay, the area, it is not a scalar quantity. In our case here, the area is a vector quantity. As you may see here, we have electric field lines. These are the electric field lines. So the lines represent the intensity of the electric field. Okay. Now, all of these lines are penetrating the plane area here, but the area itself, okay, it is pointing to this direction, you see? So actually, that vector, which is perpendicular to the plane of this area, okay, called the area vector. So we have a vector for the area. This is why we should add something called here, cosine theta, and this theta actually it is between the line, okay, and the area vector itself. Okay, so if it's like in this case, okay, so theta becomes 0 or 180. It depends actually if the lines are coming from inside or going out. Okay, and then both of these actually cosine 0, cosine 180 is just 0. Okay, so and we know in this case we will get cosine. Sorry, cosine 0 is 1. Sorry, cosine 0, okay, is 1. It's not 0. This is the maximum that we can get. So we can call this one max. Sorry. Okay. So the maximum result may be positive or negative. It depends on the angle that we are taking. Okay. And we know the phi, which is positive, that means the lines are coming from in, going out. Okay. If the more lines coming from out, going in this case, we call it a negative value of phi. But phi itself is not a vector. Okay, E is a vector and A is a vector, but phi itself is a scalar. Okay, which is the result of these two together. Okay. So now we should know what is the value of E. Is it changing? Okay. Also, what is the value of A? Is it a fixed area? هل أيضا المساحة هي ثابتة محددة ولا هي أيضا جالسة تتغير؟ تمام. If it's changing, so then we should also sum up all of these, added differential area, which is a small area. Okay. Inshallah, we will see an examples on all of these what I'm now speaking about. Okay. Let's go for the first problem here. Now we are looking for phi. Okay. But we know that electric field is uniform, so it's constant. So the electric field here is constant, and it has two components here. You see, what is J and what is K? Actually, these are like this. You see, we have this Cartesian coordinate, it has X, Y, and Z, you see. X, actually, we have another notation for X, which is I. Okay? And we have another notation for Y, which is J. So we can say this is J direction or positive J direction, and we have here the negative J direction. Okay? We have here Z, which is, in this case, in our notation, is K. So we can say we have a coordinate components they are perpendicular to each other, I, J, and K. Okay. Also, we have minus K down here. We have here also. Okay. Can take that one also, okay, as the opposite of X or opposite of I. Okay. Now, understanding our coordinate, we see that we have only two components. So one of them is 4.0J. So that means some of the lines, let's draw them by blue color. Some of the lines, they are moving from left to positive J, because this is positive. So we have lines of electric field are going that side, this direction. Okay. So this line is not only one, we have many of them are going in this direction. And then we have another ones that are coming from bottom here, going to the positive K. Okay. They're coming from down here, going up. And the amount of that one is 3.0 in K directions. So actually we have a perpendicular components. One is going to the Y direction, to the positive Y, J, and the other one is going to the positive Z or K. Okay. Okay. Now we know the direction of the electric field, which is this one. Now we're looking for the area. Okay. So where's the area? The question said here that the circular area is lying or staying يعني مكانها في XY plane. The XY plane هي هذه. اللي هي وين XY plane? We know this is X and this is Y, which is I and J. Okay. So this one here. Okay. So we can't take the other one from there. يعني ممكن ناخذ هذه أو هذه يعني بالنهاية between X and Y. Okay. And in this plane يعني في هذه المنطقة في هذا الربع we should draw اللي هو إيش circular or circle اللي هي الاريا اللي it has radius of 2 meters. So R هنا okay, is equals to 2 meters. 2.0 actually. About 2 meters too large. Okay. Now we know where is the area, but we should ask ourselves about not the surface of the area, but the vector of the area. So we know إذا كان عندك صفحة أو ورقة مثل هذه، خلينا نأخذ الحين أي ورقة مثلا هذه الورقة. هذه الورقة يمكن تشوفوني في الكاميرا واضح ولا لا؟ الحين هي مقبلة فوق صح؟ فمعناته الفيكتور راح يكون to the top here. Okay. فكل هذه الاريا okay, it represented with one vector to the top. طيب هذه لو الحين تحركت نحو كذا، فالحين راح أشوف إنه هذا البيبر now is pointing this into this direction, so the vector will be in this direction. Okay, so this is why now we are taking the vector okay, to K direction like that. Okay, so this is the A vector, and this is actually the E vector here. Okay, so all lines of the electric field are coming up like that. Okay. Now, if I ask you the question, which lines that should penetrate, okay, fully go through the surface of that plane area, actually, if you can see, you see that most of the K directed, okay, electric field lines, they can penetrate easily from that area, okay. But what about this, which is the 4 here, 4J? You see, electric field has two components. Okay, what about these ones? Yeah, these are going to the Y direction. So actually, all of these lines, يعني احنا رسمنا واحد, but we can draw many of them. Most of these lines, they just go parallel to the surface. Okay, so they will not penetrate the surface. So they go only parallel to the surface. And the angle here will be 90. And cosine 90 is 0. In this case, now we are taking only the second part. So this part, okay, is important for us because it can give us the result. But in the J direction, because the theta here between I, okay, so between E and A is equals to 90. So we'll not take this part of the electric field. Okay. So let's answer now the question, okay, by using the normal, relation between phi and all of these directed area directions. Okay. So phi equals, okay, E into A, and we know these are directed, and we know there is no angle, so no need to draw an angle because the other part of E is just perpendicular, and cos theta is 0, so no need to mention it there. And then we can say that we have only 3.0, okay, in the K direction. Don't forget to multiply it by 10 to the power 3. Okay, and this is actually multiplied by, we know the area of the circle, which is by r squared, and we know r equals to 2 meters. Okay, and also this one, it has the direction. Don't forget that this is the K direction here. Okay, so both are in K direction. So in this case, we can get the final results if you substitute r by 2 and then square it, then you can get 4 pi. And here we have 3, so 12. Okay, and we have 12 multiplied by pi, that will be 3.8, but in this time 10 to the power 4. Okay, don't forget the unit. Usually students, they forget to write the unit. Newton per coulomb into that area, which is meter squared. Okay, is this clear? So don't forget to ask yourself whether this electric field is constant or is it changing. Okay. Inshallah, now we'll see an example of changing electric field. Okay, this is just a revision for what you have studied from before.